Hello everyone. On this video we will take a quick look at one-sided limits. Okay, so first we'll look at the limit from the right as x approaches c. So that's the limit of f of x as x approaches c from the right will equal some value that we'll call L. And you have the limit from the left as x approaches c. That's just the limit of f of x as x approaches c from the left equals some limit value that we will call L. Alright, so if we looked at a number line, just kind of give you a visual. And this is your x-axis and you're approaching some value c. If you're approaching from the left, that would be your c with the little minus sign up there. If you're approaching from the right, that would be c with the little plus sign up there. Okay, don't confuse that with positive and negative. It's not positive and negative. It's literally just from the left and from the right. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our examples. Alright, so let's say for example, if we wanted to find the limits for problem A, that would be the limit the square root of 4 minus x squared as x approaches 2 from the right. And for B, we have the limit of the absolute value of x over x as x approaches 0 from the left. Okay, now just like any other limit problem, if you can use direct substitution, by all means use it. Okay, so for problem A, you have the limit, the square root of 4 minus x squared as x approaches 2 from the right. We're just going to go ahead and plug it right on in. So use direct substitution. Alright, so you have the limit. I'm just going to go ahead and rewrite it. 4 minus x squared as x approaches 2 from the right is just the square root of 4 minus 2 squared, which is 4 minus 4, so that's just square root of 0, which is just 0. Okay, so if we were to look at that as far as a graph, that's just your actual answer here, just 0. We will look at the actual graph of that problem. You have your x and your y-axis. Square root of 4 minus x squared looks something like this, where it goes from 2 to negative 2. Okay, and you're going to be approaching 2 from the right, while the actual limit at the point 2 from either right or left is going to be 0. That's your f of x value. Alright. Now, let's look at a problem where you can't use direct substitution. Okay, so let's say for problem B, you have the limit, the absolute value of x over x as x approaches 0 from the left. Okay. Now, drawing a number line here may help, even though it's a crooked number line. Hopefully that doesn't bug you too much. So what if that's our 0? Okay, so we know that when x is greater than 0, all values are positive. And when x is less than 0, which is everything to the left, all values are negative. Oops, here we go. Okay, so that means since x is approaching 0 from the left, it's approaching 0 from this direction. So x approaches 0 from the left. So we know that all the x values are negative. Okay, so how do we use that? Well, we know that we have the limit of the absolute value of x over x as x approaches 0 from the left. Since all the x values are negative when you approach it from the left, that means we're going to have the limit of, well, actually it wouldn't be the limit because all of our values would be negative. So we have the absolute value of negative x all over negative x. Okay? Now if you wanted to, you could put the limit there, which is, actually I would do that just to kind of keep it consistent. Limit as x approaches 0 from the left of absolute value of negative x all over negative x. Okay? Now the reason I said that you can take the limit out is because this is actually going to simplify. That is going to equal the absolute value of negative x. So if you have the absolute value of negative 4, that's going to be 4. If you have the absolute value of negative 8, it's going to be positive 8. So the absolute value of negative x is just going to be positive x. And here you have the negative x, which is no absolute value, it's just negative x. So you have x over negative x. Okay, and anything divided by itself is just 1, and you have that negative, so that's going to equal negative 1. Okay, so actually that would have just been the limit of negative 1, which is negative 1. That's why I was saying that the limit was actually optional at this point, but I went ahead and wrote it in anyway. Alright, so here, the limit of absolute value of x over x, as x approaches 0 from the left, is equal to 1, negative 1. Okay, now if you did the same thing for the limit of absolute value of x over x as x approaches 0 from the right, you would actually get positive 1. Because all the x values are positive, and you'd end up with x over positive x instead of x over negative x. Alright, so hopefully this made sense, and I'll see you on the next video.